The modular site project by Dr. George Maynard is, from what I can tell, the in-universe explanation for why the facility in SCP Containment Breach has a different layout on every playthrough. Upon starting a new game, the game will take all these prefab rooms and string them together at random to form the scary nightmare labyrinth that we call home. This begs the obvious questions. How was the facility created? What all is the game doing during the stall at 45% loading progress? What kinds of horrendous spaghetti that calls itself a random generation algorithm are we about to read through? And my biggest curiosity, why is the entrance zone so small? All that and more will be answered in this month's episode of Containment Breach-EX. I must let you all know up front that I am only 95% confident in my explanation here today. There is a lot going on with this code, and it's entirely possible I don't have the facts 100% correct. Should I learn of any mistakes I may have made, I'll post corrections in a pinned comment below. Now, let's begin. When the new game button is clicked, a random seed string is created and placed into this box. The seed has a 1 in 15 chance of being one of these 13 pre-made strings, chosen at random. These include spooky messages, threats from SCP-173, developer inside jokes, and a Homestuck reference for good measure. If the 1 in 15 chance fails, then it makes a random string of characters instead. A length between 4 and 8 inclusive is decided, and for each character, there's a 1 in 3 chance of placing any single digit, otherwise place a random lowercase letter. Repeat until the total length is hit, and then throw it in the box. Of course, the player can change the string to whatever they like, including nothing at all, in which case the game will just grab how many milliseconds the game's been running and use that as the seed. Once start is clicked, the game will convert the random seed string into a number and set the RNG seed to that number. Then we load the game's entities and sound effects into memory, which takes up the first chunk of the loading screen. At 45% loading progress, the function initNewGame is called. This function prepares some values and also creates Dr. Maynard's office code, which is based on the seed we set. Then it checks if the player has set a custom map. If they haven't, then we have to create a map. Here's our stop. Create map starts by converting the random seed string to a number and setting the RNG seed. Didn't we just do this? Whatever. The more important question is, what exactly is an RNG seed? Lots of videos have been over this before, so if you already know, then feel free to skip ahead. In order to create random effects in programming, the computer is told to generate a random number. Random is in quotes because computers cannot actually do that. Whatever number they give is always determined by some outside factor, such as the computer's current date and time. Since it's extremely unlikely that you'll run a program with the exact same clock values, the random numbers generated by the game are all but guaranteed to be different between play sessions. So basically, most modern programs use your computer's current date and time and create an RNG seed from that. But again, what exactly does that mean? Most RNG functions used for video games work like this. Whenever RNG is called, a number is put through a series of arithmetical and/or bitwise operations, which changes it to a completely different number. That number is the random number which the program was looking for, maximum or minimum limits notwithstanding. So it's returned for use by the program and also saved, so that it can be used as the input for the next RNG call. Since the operations performed on the input number are just a slightly more weird formula, this means that the same input values always produce the same output values, and the same input value for the first RNG call will always produce the same sequence of random numbers. This first input value is known as the RNG seed. If we change it, then the sequence of random numbers changes as well. So when we set an RNG seed at the beginning of map generation, this sets the first value that will be input into the RNG function, and every RNG call that occurs during map generation will be based off of this seed. If we use the same seed for 2 different playthroughs, every RNG call during map generation will produce the same numbers, and thus build the same facility. Okay, with that cleared up, let's get to building the map. The rooms of the facility are placed on a grid with a default size of 19 by 19. This size comes from options.ini, and yes, it is possible to edit this value and cause the game to generate giant maps or even tiny maps, but for this video I'm only interested in the default map size of 18. The grid is made one room larger than the map size value in both directions. The grid is split between the three zones of the facility: light containment, heavy containment, and entrance. These two rows here are the borders between zones, which is where the checkpoints are placed. The colors of each zone will look a little weird here because I put invert colors onto this footage to not kill your eyes. Generating the facility takes 4 distinct steps. Step 1. Decide which spots on the grid will be rooms. This will create the base layout of the facility. Step 2. Count how many of each room type we have placed and make any necessary adjustments. Step 3. Choose where the important rooms should go and then actually build the rooms. And step 4. Do some final touch-up. Each of these steps is quite involved, so let's break each of them down. Starting with step 1, we set a pointer to this square towards the bottom of the map. This square and the one below it will be set to true, which essentially places a room there. We then want to build a long horizontal hallway along this row of the grid. We roll a random value between 10 and 15 inclusive. Almost all random number ranges will be inclusive going forwards. And this value is how many rooms long the hallway will be, with an asterisk. We'll have to adjust the pointer's X position to build the whole hallway, and in this case, we do so by subtracting half of the width value from X, which puts us here. Note that this view of the facility grid is rotated upside down from how the grid would look normally. So 0 on the X-axis is the right side of the grid, and 0 on the Y-axis is the top. It's a bit confusing, but it matches how the facility is oriented on the S-nav, so I'm gonna keep showing it this way. We then make sure the hallway won't be too long, as the game prefers not to place rooms within these outer areas of the grid. In this case, the hallway will fit, so each room is placed down from right to left. Once the horizontal hallway is built, we now want to build a number of vertical hallways that stretch north. We choose whether to build 4 or 5 vertical hallways, and then we choose if they should be up to 3 or 4 rooms long. However, this first case will always see the vertical hallways being 3 rooms long, because if the last room of a vertical hallway would land on the border between zones, the length of the hallways is reduced by 1, because those 2 rows of the grid are reserved for checkpoint rooms. Anyway, now we start building the vertical hallways. The first one will always be placed on either of the 2 ends of the horizontal hallway, which is chosen with a coin flip. The hallway will also always be the maximum length of this set of vertical hallways, which in this case is 3. The remaining hallways will be placed in a random spot along the horizontal hallway, including the very right side, but excluding the very left side. Only the first vertical hallway can be generated on the far left of the horizontal hallway. Each remaining vertical hallway will have a random length of 1 up to the maximum length for this set, which again is 3. Additionally, a vertical hallway can only be placed in the selected spot if the 2 surrounding spots on the grid are clear of rooms. If there's a room within this zone, we move left until we can find a clear spot. Now that every vertical hallway is built, we can see that sometimes vertical hallway is a misnomer. This one in the middle only placed 1 additional room above the horizontal hallway, which will eventually become a dead end of some kind. However, these rooms are created as a result of the game trying to put a hallway there, so I'll keep referring to them as such. With all that done, our pointer moves to the top room of the longest vertical hallway that was placed most recently. In this case, that's here. We'll then build another horizontal hallway along this row, though where we start depends on where the pointer is. This spot is at x equals 11, which means we have to do some funky things. We set our generated width value to negative, then check if x plus this value is out of the bounds of where we'd like rooms to go. In this case, it is, so we'll set width to the negative of the pointer's x position, which is 11, plus 2. This leaves us with a width value of -9. The pointer uses this to move down by 9 spots, and width is turned positive just in time for the hallway to be built. Despite the width value being 9, this hallway ends up being 10 rooms long, because this room was already here from the vertical hallway. Now it's time for 4 more vertical hallways, and these ones can actually be given a max length of 4, since their last rooms will never hit a checkpoint border. However, in this seed, every set of vertical hallways ended up with a max length of 3, so we'll just do that again. We put the first hallway on the far right, put another here, and another here. Then we try to place a fourth in this spot. But there's a problem. Not only is this spot invalid, but the spot right next to it is also invalid, because remember, vertical hallways beyond the first cannot be placed on the far left side of the horizontal hallway. And because the search for a valid spot doesn't loop back around to the right side, this hallway has nowhere to go and thus doesn't generate, leaving us with only 3 vertical hallways built instead of 4. The final thing to note about this is how all of the rooms placed within either of the checkpoint borders are given a value of 255, which is basically a sticky note reminder telling the game to put a checkpoint there later on. From here, the cycle repeats. Build a horizontal hallway with a random length, making any needed adjustments to the length based on the pointer's position. Build 4 or 5 vertical hallways stretching further north. Make sure at least one of them is the maximum length so that the facility is actually traversable. And repeat until the pointer's Y position is within the top 2 rows of the grid. Then, we stop there and the base layout of the facility is finished. Here is why the entrance zone always generates so small. The game will go through the hallway building cycle once, then see that it's reached the top of the map and stop there before another horizontal hallway can be built. If the game was allowed to build one more horizontal hallway before stopping, the entrance zone would end up a lot larger, around the same size as the other zones. There's also something a little weird going on over here. This vertical hallway is outside the bounds of where the game prefers rooms to go, so how come this was allowed to be built? Well, this horizontal hallway had the pointer starting here, at x equals 8. The generated width value for this hallway was 14, and because of where the pointer is positioned, the pointer was moved 7 spots to the right, which placed it here. When the game ensures the hallways remain in bounds, it only checks for the pointer's x position plus the width value. It doesn't check for the x position alone being in bounds, so this is seen as a valid starting position for this hallway. The same goes for the horizontal hallway in the entrance zone, since the pointer's initial position and the width value ended up being the same as the previous hallway. So it is possible for rooms to generate on the far right side of the grid, but it's very unlikely that they'll generate on the far left side. The game does a much better job of keeping them out of there, since the hallways are built from right to left. Okay, that's step 1 complete, but we are far from done. The next thing is to count how many of each room type we've placed. Every room in Containment Breach falls under one of 5 different room types: Room 1, Room 2, Room 2C, Room 3, and Room 4. The number in each type is how many exits the room has. Room 1s only have the one exit, which forms a dead end. Room 2s have 2 exits placed across from each other, forming a hallway. Room 2Cs have 2 exits placed perpendicularly, forming a corner. Finally, Room 3s have 3 exits with the remaining side having none, and Room 4s have an exit in every cardinal direction. To find which of the placed rooms fall under what type, we look for how many rooms they're connected to, and save that value in that spot. Repeat for every room on the grid. We'll also keep a count of how many room types there are per zone, which is used to ensure the facility generates how we want it to. More specifically, we want each of the 3 zones to have at least 5 Room 1s, 1 Room 2C, and 1 Room 4. If any zone has less than 5 Room 1s, then we find places to add more of them until there are 5 of them. And here's where I must admit that my knowledge is lacking in this part of the process. That is, I don't know how the game chooses where to put these rooms. What I do know is that the game will look for empty grid spots directly adjacent to Room 2s or Room 3s, and if there's enough space around it, it'll add a Room 1 in that spot and convert the Room 2 or 3 into a Room 3 or 4, respectively. In the example seed, the light containment zone currently has 4 Room 1s, including 173's chamber, so we add one more right up here and turn this room into a Room 3. So to clarify, I know how the game adds more Room 1s, but I don't know why it chose this spot specifically over all the other spots right down here. It seems to search through the zone from the bottom right corner up, but then that makes it all the more confusing why it ignored all of these areas. It doesn't matter too much though, all you need to know is that the game ensures there will be 5 Room 1s per zone. This can fail if the game simply can't find any room for another Room 1, but it is very unlikely to work out that way. If a zone has no Room 4, then we must try to fit in one of those as well. In the example seed, the entrance zone doesn't have a room 4, so we find this room 3 here, and provided there's adequate space, we stick a room 1 on the empty side and convert the room 3 to a room 4. Mission accomplished. It is possible for this to fail if we can't find adequate space around any room 3 in the entire zone. Finally, we have to try and fit in a room 2C in each zone. The example seed generated room 2Cs in every zone already, so there's no need to do that here. But if it was needed, we'd find a room 1, and provided there's adequate space, we would push it back at an angle and add 2 extra rooms that lead to it, one of them being the room 2C we desire. Here's an example of this happening. On this seed, the heavy containment zone had no room 2Cs placed in it, so it moved and rotated 106's chamber over here to add one in. This can also fail to occur if no room 1 has enough space behind it, which can be a big problem if this failure happens in the entrance zone. Without any room 2Cs in the entrance zone, the electrical center will fail to generate, and the map will become unbeatable. This doesn't happen too often, but it's still a very real possibility. Whether or not those last 2 processes succeeded, the room types are now set, step 2 is completed, and we're now ready to build the map for real. Every room in the facility is one of 2 kinds. An important room, which appears only once per map and usually contains something noteworthy that you can't find anywhere else. Or a filler room, which can appear multiple times per map and whose only real purpose is to connect you to other rooms. Before we can build the rooms, we first have to decide where all the important rooms are going to go. This is done by using a 2D array called Map Room. The array contains a spot for every room that has been placed by step 1 and 2, split up by room type. To decide where the important rooms should be placed, a spot in the map room list is set to that room's name, which the game will refer to later when it's building the rooms. For example, the first room under room 2 in the map room list is always set to room 2 closets, which is the place where SCP-173 kills 2 people during a brief blackout. The map room list is saying that the first room 2 to be built in the facility will be room 2 closets. The room building process starts from the bottom right corner and moves up from there, so this means that the room 2 farthest to the right on the bottom horizontal hallway will almost always become room 2 closets. Almost always. There is a way for it to not be placed there, which I will cover later. Rooms are assigned to the map room list in 2 ways, either by setting it to a spot on map room directly, which will overwrite any room that may have been in that spot, or by using a function that will only add the room to map room if it can find an open spot. The function is given a starting position and a minimum and maximum position, giving it a small zone to search for an open spot. It'll first search ahead of the starting position for an open spot, but if it can't find one there, it'll wrap around and search the area behind. If an open spot is found in either area, then the room is successfully added to map room. If no open spot is found anywhere within this zone, then the room isn't added and will not be built on the map. So if the heavy containment zone somehow doesn't have 5 room 1s in it despite step 2's efforts, then SCP-895's chamber will be the first room to go, as it is added last out of all the room 1s in heavy containment. The starting positions for each added room will be placed further and further in the facility from the bottom right corner, and the exact positions are determined by how many of each room type are present in the map. This is done to avoid having every important room bunched up together on one side of the facility. One outlier in this process is the room that leads to Storage Area 6, which has a small randomization applied to where it will go on the map room list. It is the only room to do something like this. Another fun fact is that the first room 2C that generates is set to a lock room, even though lock rooms are filler rooms that can appear multiple times per map. The same kinda applies to room 2 GWB, the broken decontamination room. This room is not actually a filler room and is set to the map room list, thus appearing only once per map. Since the positions of these rooms are determined by how many rooms there are, where these rooms go differs greatly from seed to seed, so I won't be able to give much more info on that. Either way, this process repeats until every important room has at least attempted to find a place on the map room list. Now it's time to build the rooms. Finally, right? As mentioned before, building the rooms starts from the bottom right corner of the facility. For each room, we'll grab its room type and check the map room list under that room type. If a room is set in that spot of the list, then we'll build the specified room. If the selected spot is blank, then we must choose a filler room to build there. This involves yet another lengthy process. First, we find every filler room with the matching type and zone of this room spot and sum up their commonness values. The commonness value of a particular room can be found in the rooms.ini file. If a room has a commonness of 0, then it's an important room and thus cannot be placed as a filler room. Unless you edit the file, of course. Anyway, we take the summed commonness values and generate a random number from 1 up to that value. Then the value is reset to 0, only to start summing up the values again. We go back through the list of possible rooms, and for each one, we add its commonness to the value and compare it with the random number generated prior. If the random number is between the value and the value minus the current room's commonness, then the currently selected room is what will be built here. Otherwise, we move on to the next room candidate, add that room's commonness to the value, and run the check again. To put it more simply, here's a number line and here's the order of light containment zone filler rooms the game iterates through. Each room has a range along the line, whose size is equal to the room's commonness value. Whichever range the randomly generated number ends up in, that's the room that will be built. There are 3 more things we must do in the room building process. First of all, if the value of the room spot is 255, we check what height the room is at, and then place the appropriate checkpoint there. For non-checkpoint rooms, we have to make sure they're oriented the right way, which is pretty straightforward. For Room 1s, Room 2Cs, and Room 3s, we just turn them so that they face their adjacent rooms. Room 2s are the same, except we also flip a coin to decide the hallway's rotation. Room 4s have no angle adjustments needed, so they always use the default of 0. Finally, upon being created, every room calls fill room, which places all the necessary entities, items, non-connecting doors, etc. inside of them. The most notable things about this function is that it's responsible for generating the random items inside the Room 1 archive rooms, and it's also what places a code-locked door in the checkpoints if there's no room above them. Fun fact about code-locked doors, however, even the doors you're not supposed to open still have a code set. For the checkpoint rooms and this one in the server room where you encounter SCP-096, the code is set to gear, and for all the others, the code is set to ABCD. Since the keypad can't type letters, these doors can't be opened. Also, the door to Dr. L's office is given the code 1234, which can be input, meaning you can close this door if you want to. Anyway, repeat the above steps for every room, and now the whole facility has been built. And we're still not done. It's now time for step 4, which begins by adding all the extra rooms that aren't attached to the facility. Namely, SCP-106's pocket dimension, the SCP-1499 dimension, the Gate A ending zone. Gate B's ending zone is attached to the entrance room, kind of like Storage Area 6 or 049's chamber. And the room containing the intro sequence if it was enabled. Then, the game will try to prevent rooms from overlapping. Yeah, I'm shocked too. For how commonly experienced of an issue this is, it's surprising to see that the game does try to do something about it. But how well does it try? For every room in the facility, we'll check if it's overlapping any other rooms. If the selected room is a checkpoint, 173's chamber, or has disable overlap check set to true, then we don't care. For everything else, if it is overlapping another room, we'll first check if the selected room is a room 2. If it is, we'll rotate it by 180 degrees and see if that fixed the problem. If it didn't, or if the room isn't a room 2, then we'll find another room with the same type and zone, and swap places with it. If the rooms aren't overlapping anything in their new positions, then mission accomplished! This is why the Room 2 closets won't always spawn in the bottom right corner of the map. Here's one such seed where this happens. If we reconstruct the seed in the map creator, we can see that Room 2 closets is right up against a bunch of rooms, including the surveillance room, which absolutely does overlap with it if rotated the right way. This overlap doesn't cause any problems, but it's enough for the game to notice and try to fix it, which is exactly what it has done. So if Room 2 closets is not located in the bottom right corner of the map, then that means it was moved somewhere else because it was overlapping with another room. Anyway, if none of the rooms with a matching zone and type fix the overlap issue, then we just throw up our hands and leave it, forcing the player to put up with the consequences. Since this is such a common bug, I'd rather the game would scrap the map and build a new one if it can't fix an overlap issue, but I understand that could cause other issues, like really long loading times or less map variety. Still, it would be nice if every map the player is given was beatable. Regardless of whether or not we succeed at fixing room overlap, we then try to run some debug code. This code appears to print out some kind of map for the facility that was just generated, which is clearly meant for the developers in order to help fix bugs. All of this code is wrapped in a check for if zero, then, which is programming speak for never run this. If the devs wanted to see this map, they would just change this value to 1 or true, and it would work. Anyway, what we actually do next is place all the doors throughout the facility, making sure to use the heavy containment doors when appropriate, and rolling a 1 in 5 chance to have the door be opened by default. Every opened door also runs a 1 in 8 chance to be an auto-close door, which makes SCP-079, the computer, slam it in your face when you walk up to it. And with that, Create Map is done. If you're wondering why the game always stalls at 45% loading progress, that's because it's running this function during that time. If I had to guess, most of the lag comes from building the actual rooms, since there's a lot that has to be done there. Speaking of being done, we still aren't. That was just the start of a new game. There are still 142 lines of code left. Fortunately, most of it is just boring setup stuff that we don't really care about. It places waypoints, spawns 173 and 106, gives 106's initial random spawn timer, gives each door a button, places random decals on the floor, gives the player the 2 starting documents if they skip the intro, turns the player to a random angle between 160 and 200 degrees. But then, if this isn't a custom map game, we have to place room events. Room events are the lifeblood of SCP Containment Breach. Without them, barely anything would be interactable at all, and the game would be quite empty and boring. So, we must implement them into the map by calling init events. Init events will assign each possible event to its respective room using the function createEvent. The createEvent function is passed an ID value and a probability. If the probability value is set to 0, then this event will be assigned to the instance of this room in accordance to the ID value. For example, if the ID is 0, then the event will be assigned to the first instance of the room in the facility. 1 is the second instance, 2 is the third, and so on. If the probability is higher than 0, then the event will attempt to be assigned to every instance of that room, with each instance rolling the given probability of being assigned. A perfect example of both of these methods is the event Lockroom 173. If this 2 in 3 chance succeeds, Lockroom 173 will be assigned to the first lockroom on the map, guaranteed. Right afterwards, Lockroom 173 is assigned again, except this one is given a 30% probability, meaning that every remaining lockroom on the map has a 30% chance of having Lockroom 173 assigned to it. Oh yeah, and Lockroom 173 causes 173 to spawn inside the lockroom when you get close to it. In addition, the probability of the second Lockroom 173 placement is increased to 80% on Aggressive NPCs mode. This also occurs with other events later on, meaning that turning on aggressive NPCs will slightly change how certain events are placed throughout the facility. From here, init events goes through each event and places, or attempts to place them, in their respective rooms. Let me give you the highlights. Endroom 106 can be assigned to the first or second endroom on the map, chosen at random. Room 2 elevator can go in the second or third Room 2 elevator on the map, but never the first, which will always have Room 2 elevator 2. Tunnel 2 will always be placed on at least one of these tunnel rooms, but if Aggressive NPCs mode is on, every other instance of these tunnels has a 20% chance of having it assigned. Room 2 Offices 2 only has a 70% chance of spawning the anomalous duck inside of each one. I was under the impression that they always spawn, but I guess not. 6A2 Roar can be assigned to either Tunnel, Room 3 Pit, or Room 2 Z3, but also has a 1 in 5 chance of being excluded from the map altogether. Similarly, 895's chamber has a 1 in 5 chance of not spawning 106 if you walk up to the coffin. The guard will still fall, however. SCP-1048-A can be placed in various light containment zone hallways via custom maps, but random maps will only place him in the basic light containment room 2, and he is guaranteed to appear in every single one of them. All Tesla gates have a 90% chance of having the Room 2 Tesla event assigned, which is what makes the Tesla gate active. This means that each Tesla gate has a 1 in 10 chance of being deactivated. Which rooms the 106 victim and 106 sinkhole events spawn in is decided on a coin flip. Somehow, in one of my past playthroughs, these two events swapped places upon me loading a new game with the same seed, even though that should be impossible. I don't know what happened there. 096 spawn has many different rooms that it can be assigned to, each one having a chance that increases if aggressive NPCs is on. And that's about it with events, the interesting stuff at least. Before wrapping up, I should make note that the probability you have control over in the map creator is the same probability that is passed to create event. I assumed that this probability was the chance of the event triggering whenever you entered the room or whatever, but no, it's the chance that the event is assigned to that room upon starting a new game with that map. This is an important distinction to make, especially for spawn 096. You're not setting the chance of 096 spawning in that room as you play, you're setting the chance of 096 being allowed to spawn in that room on any given playthrough. Finally, none of the previous event setting stuff applies to custom maps, because the game will just assign the events as you've set them yourself in the map creator. With the events all placed, we set certain event states to 1, hide the mouse cursor, do some preliminary world updating, and we're done! The game is finally ready to be played. Now, technically speaking, we still aren't done. After all, there are two other parts of the game that are also randomly generated, the maintenance tunnels and SCP-860-1. However, figuring out how the facility is built was difficult enough that I'm not going to include the other two areas in this video. They've got their own barely readable algorithms that I'll have to figure out someday, but for now, I think this is good enough. I can at least say this. While SCP-860-1 is generated during Room 860's fill room process, which takes place during Step 3 of map generation, the maintenance tunnels are actually not generated until you step into the room that leads to them. There's always a noticeable lag spike whenever you enter this room for the first time, and that is why. And that's the random generation. As usual, it's a bit of a mess, but it gets the job done. It keeps the game's solid progression structure intact, while still feeling different enough on every playthrough to not get stale. And I find it awesome to see all the code responsible for the creation of one of the most iconic horror game settings ever made. This was easily the most confusing topic I've covered so far, so it's surprising to see that my script is not quite as long as some of the previous videos. I'd like to give a huge thank you to Amberblaze for helping me figure out this code, and to Suslik for making the Mapseed viewer website, which was a great help for making this video. And of course, a huge thank you to you all for watching. I hope you enjoyed the video, and I hope you learned something new in the process. Next up, I'm planning to start getting into the enemy SCP's behaviors, starting with 173. But before that, there is a video I'd like to make that, while not SCP-related— shut up. The first time someone's called me while recording voiceover. There is a video I'd like to make that, while not SCP-related, is going to be somewhat similar to these videos. And it involves a certain underground indie game called Hollow Knight? You've probably never heard of it. That video will likely come first so that I can shake things up a little, but don't worry, more Containment Breach-EX will be coming your way for as long as possible. Thank you all for watching if you did, and as always, I will see you all in the future.